Welcome viewers to the third module of problem solving and decision making course. It deals with application of advanced tools and techniques. The first part deals with linear programming. Coming to the objectives. At the end of this session, you will be able to identify problems associated with linear programming. You will be able to formulate an LP. You can find optimal solution of an LP problem graphically and through MATLAB solution. Maximization and minimization problems, how to solve integer linear programming, how to solve binary integer linear programming, and finally, branch and bound method to solve an ILP will be introduced to you. So coming to the linear programming introduction. A linear programming is a widely used mathematical modeling technique designed to help managers in planning and decision making relative to resource allocation. Linear programming is a technique that helps in resource allocations and decisions. So mind it that linear programming is basically deals with the resource allocation, and it can be done with the help of programming, that is modeling and solving a problem mathematically. Coming to the certain examples of successful linear programming applications. There are a number of examples around you. You definitely come across different types of examples in which you have to find maximization or minimization problem. In other words, you have to optimize certain problems, either maximization or minimization. You may come across development of a production schedule that will satisfy future demands for a firm's production while minimizing total production and inventory cost. Selection of product mix in a factory to make best use of machine hours and labor hours available while maximizing the firm's products. So generally, you come across these two types of problems in your factory, in your office, or in your warehouses. Then determination of grades of petroleum products to yield the maximum profit. Selection of different blends of raw materials to feed mills to produce finished feed combinations at minimum cost. And determination of a distribution system that will minimize total shipping cost from several warehouses to various market locations. These are basically main concern where we have to optimize our solution. So linear programming problem deals with basically optimization. And it has four properties in common. If these properties are there, we may say that this is a linear program. First of all, it must have an objective function. And that, what is objective function? That is, all problems seek to maximize or minimize some quantity. That is the objective function which we have to optimize and which we have to maximize or minimize. And there must be certain restrictions or constraints under which we have to obtain our objective function. And there must be alternative courses of action to be chosen from which we can choose the best option for our maximized or minimized objective function. And finally, the objective and constraints in linear programming problems must be expressed in terms of linear equations or inequalities. So these are four conditions which must be met. 5 basic assumptions of linear programming. These 5 assumptions are: number 1, certainty. That is, numbers in the objective and the constraints are known with certainty and do not change during the period being studied. This is the basic assumption. Otherwise, we cannot make a linear program. Then proportionality. It exists in the objective and constraints. And the combination of each activity to the value of the objective function, that is, or the left-hand side of the functional constraint, is proportional to the level of the activity. That is, left-hand side is proportional to the right-hand side. And if this assumption does not hold good, we have to use non-linear programming. We cannot use linear programming. What is additivity? The total of all activities equals the sum of the individual activities. This is the additivity. It must be met. Divisibility. That is, solution need not to be in whole numbers or integers. Definitely, somewhere they must be in whole numbers or integers. But it is not necessary that always, rather, it is definitely not necessary that the solution is in whole numbers. Then solutions are divisible and may take a fractional value. Then non-negativity. All answers or variables are greater than or equal to 0. Definitely, as long as we are dealing with the quantities, with the resources, you know that resources cannot be negative. So we have to deal it with variables, or we have to deal with variables which are greater than or equal to 0. So these are the basic 4 exemptions. And finally, negative values of physical quantities are impossible, minute. These are 5 basic assumptions. Okay, while formulating a linear program model, it involves developing a mathematical model to represent the managerial problem. Once the managerial problem is understood, begin to develop the mathematical statement of the problem. The steps in formulating a linear program follows as on the next slide. What are the steps? Number 1, completely understand the managerial problem first, which is being faced. Then identify the objective and constraint. You know, we have objectives, we have constraints, and we have alternatives. So first of all, after understanding the problem, you have to identify your objectives and the constraints. Then, what is on the third thing? What is the third thing? Define the decision variables. Which are your decision variables which make the part of your objective function and the constraints? Use the decision variable to write mathematical expression for the objective function and the constraints. So, this is the end of my first part. I will be meeting you in the second part. Thank you very much.